नमस्कार विद्यार्थी भाइ बहिनीहरू। आज म कक्षा 10 विज्ञान विषय अन्तर्गत युनिट 1 फोर्स विषय पढाउन गइरहेको छु र आज हामी यस लेसनमा हाम्रा टपिकहरू यस प्रकार रहेका छन्। फोर्स, हामी फोर्सको डिफिनेसनबाट अगाडि बढ्नेछौँ भने त्यसपछि जियोसेन्ट्रिक थ्योरी, हेलियोसेन्ट्रिक थ्योरी, ग्रेभिटेशनल फोर्स हुँदै हामी न्युटन्स युनिभर्सल ल अफ ग्रेभिटेसन पढ्नेछौँ भने त्यसपछि भेरिफिकेसन अफ न्युटन्स ल अफ ग्रेभिटेसन अन्तर्गत हामी F = G m1 m2 upon d square भन्ने एउटा फर्मुला डिराइभ गर्न गइरहेका छौँ। त्यसपछि युनिभर्सल ग्रेभिटेसनल कन्स्ट्यान्टको बारेमा केही जानकारी हासिल गर्नेछौँ र अन्त्यमा यसै टपिक अन्तर्गत रहेर दुईवटा न्युमेरिकल प्रब्लम्सहरू हामी सल्भ गर्नेछौँ। Okay, let us start our lesson. Unit 1, force. How can we define force? Force is an external agency that changes or tries to change the state of the body. It means that a body in rest can be changed into motion by applying force. Likewise, a moving body can be brought back to rest by applying force. The SI unit of force is Newton, and some examples of force are gravitational force, magnetic force, frictional force, centripetal force, and there are other forces also. But in this lesson 1, we'll be focusing on gravitational force in detail. Before going to the gravitational force, there are two theories related to the position of Sun and Earth in our solar system. Okay, first one is geocentric theory. In geocentric theory, the theory which states that the Sun and the planets move around the Earth. This theory is known as geocentric theory. Earth is in the center of the solar system and the Sun and the planets move around the Earth. This was the theory which was believed before 16th century, but this theory was rejected and new theory was given, that is heliocentric theory. According to this theory, the Earth and the planets move around the Sun. Means Sun is in the center of our solar system and other planets including the Earth revolve around the Sun. This is the accepted astronomical model of solar system. After heliocentric theory, we came to know that Sun is in the middle of solar system and other planets revolve around it. But the question, what is the reason behind the existence of solar system? Why the Earth is moving around the Sun and why the Moon is revolving around the Earth? So how the existence of solar system is possible? We'll be discussing about that. Sir Isaac Newton has given or has done many researches about this and finally came with gravitational force. The force of attraction between any two bodies of the universe is called gravitation or gravitational force. Its SI unit is Newton. So force of gravitation or gravitational force or gravitation is defined as the force of attraction between any two bodies of the universe. That is the definition of gravitational force, and it is a force, so its SI unit also Newton. Now, consequences or effects of gravitational force. Tides in seas and oceans occur Due to the gravitational force between the earth and the moon, due to the gravitational force between the sun and the earth, tides in seas and oceans, like that. uh, Existence of solar system is also possible due to the gravitational force. So every body in this universe, they attract each other with certain force. That force is known as gravitation. Due to that force, the solar system is possible. Sir Isaac Newton has given one law, that is Newton's universal law of gravitation. It states that the gravitational force produced between any two bodies of the universe is directly proportional to the product of their masses and inversely proportional to the square of distance between their center. It means that the force of attraction of the gravitational force between any two bodies is directly proportional to the product of their masses. It means that if masses of the bodies are increased, then gravitational force will also increase. Likewise, if we increase the distance between the two bodies, gravitational force will decrease. Now, we are going to derive, or we are going to verify Newton's law of gravitation. Okay, let us take two bodies of masses m1 and m2, and they are separated at the distance d between their centers. And the force of gravitation between them is denoted by capital F. Then, from Newton's universal law of gravitation, what do we have? We have gravitational force is directly proportional to the product of masses of two bodies. Means the force of gravitation is directly proportional to the product of masses of two bodies. It means if the masses of two bodies are increased, the gravitational force will also increase. If the masses are decreased, gravitational force also decrease. It means that more gravitational force exists between larger bodies and less gravitational force exists between smaller bodies. Like that, gravitational force is also inversely proportional to square of distance between their centers. Gravitational force is inversely proportional to square of distance between their center. It means that if the distance between the two bodies is decreased, gravitational force will increase, and if the distance between two bodies is increased, then gravitational force will decrease because they have inverse relationship. यदि डिस्टेन्स बढायो भने ग्रेभिटेसन फोर्स घट्छ, यदि डिस्टेन्स घटाइयो भने ग्रेभिटेसन फोर्स बढ्छ. So if you combine 1 and 2, we will get combined form F is proportionality sign m1 m2 upon d square. It means force, gravitational force is directly proportional to product of mass of two bodies and inversely proportional to square of distance between their centers. Or we get, now we are changing here proportionality sign into equal sign. Here we have seen here proportionality sign, but here we can see equal sign. So to change that proportionality sign into equal sign, we have to multiply by certain constant. Here we have used capital Z as a constant to make to bring equal sign here, and this capital Z is known as universal gravitational constant. This is universal gravitational constant We'll be discussing its definition and all related terms in next topic. Therefore, we get gravitational force is equal to G m1 m2 upon d square. This is the most important formula of these lessons. Many numericals can be solved by using this formula. So this is the formula that helps us to find out the gravitational force between any two bodies of this universe. Now we have used just now we have used the capital G, and we just said that it is called universal gravitational constant. But what is universal gravitational constant? Before reading the definition, let us look here. We have F is equal to G m1 m2 upon d square. This is the formula that we derive from Newton's universal law of gravitation. You can just see here are two bodies of masses m1 and m2, and they are also separated at a certain distance. You can see here m1 is equal to 1 kg, m2 is also equal to 1 kg, and distance between them is 1 meter. So if m1 is equal to m2 is equal to 1 kg and distance is 1 meter, if we make the masses of both bodies 1 kg and distance between them 1 meter, then we can get F is equal to G. In place of m1 we put 1, and in place of m2 we also put 1, and in distance we can put 1 meter or 1. Then we can get F is equal to G. Here F is gravitational force and G is universal gravitational constant. So in this condition, if we put both masses 1 kg and distance 1 meter, we can get gravitational force is equal to universal gravitational constant. So we can define universal gravitational constant as the force of gravitation that exists between two bodies of masses 1 kg each, separated at a distance of 1 meter. Just now we have seen that if the distance between two bodies is made 1 meter, and if their masses is 1 kg and another mass is also 1 kg, then we can get universal gravitational constant is numerically equal to the gravitational force. So this is the definition of universal gravitational constant. And the numerical value of gravitational constant G is 6.67 into 10 to the power minus 11, and its unit is Newton meter square per kg square. So the value of universal gravitational constant is 6.67 into 10 to the power minus 11 Newton meter square per kg square. So in many numericals, the value of capital Z is not given. You have to remember this in your mind so that you can easily solve the numerical problems. Okay, now we'll be moving towards the numerical problems. Here I have given you one numerical here. Just let me read. What is the change in the gravitational force between two bodies if the distance between them is half, keeping their masses constant? The question ले के भन्न खोजेको छ भन्दा हेर, what is the change in the gravitational force? ग्रेभिटेसनल फोर्समा के चेन्ज आउँछ होला यदि हामीले दुईटा बडिजहरूको बिचको डिस्टेन्सलाई हाफ गरिदियौँ भने, यदि डिस्टेन्सलाई हामीले आधा बनाइदियौँ भने उनीहरूको मासेसहरूलाई हामीले केही पनि चेन्ज नगरिकन मासेसलाई कन्स्ट्यान्ट राखेर यदि दुईटा बडिजहरूको बिचको डिस्टेन्स हामीले चाहिँ आधा गरिदियौँ भने अब नयाँ फर्म हुने ग्रेभिटेसनल फोर्स बढ्छ घट्छ अथवा कतिले बढ्छ कतिले घट्छ, त्यो कुरा चाहिँ हामी फाइन्ड आउट गर्न गइरहेका छौँ। अब सोलुसनतिर हेरौँ। अब हामीलाई थाहा छ the gravitational force between two bodies of masses m1 and m2 separated at a distance d is given by. We have derived that formula also. If there are two bodies m1 and m2 and they are separated at the distance d, the force of gravitation is given by F is equal to G m1 m2 upon d square. This is the formula that we have derived already. Now the condition is given in the question. According to the question, the distance between the two bodies is halved. Means distance become d upon 2. Means if we divide the distance by 2, we'll get half. So distance is halved here. So you can just see the figure. Here m1 and m2 are the two masses and the distance between them is d upon 2. So in this condition, new gravitational force, there will change the gravitational force because we have decreased the distance, and the new force of gravitation is denoted by F1, and here we have using the force formula of gravitation, F1 is equal to G m1 m2, because we are keeping the masses constant. Here we do not change the masses, so m1 and m2 is the same here, and in place of d square we put what, d upon 2. So d upon 2 whole square, f1 is equals to g m1 m2 d upon 2 whole square. So if we solve it, f1 equals to g m1 m2 upon d square by 4. Next step, f1 is equal to d square by 4. You can just see here uh, d square by 4, we change that into its reciprocal form, and this 4 comes off. The fraction is changed into reciprocal form while coming off. So f1 is equal to 4 g m1 m2 upon d square. This 4 has gone off. So we get here finally what we get, f1 is equals to 4, same here, g m1 m2 upon d square. If you look at here, g m1 m2 upon d square is equal to f. So in place of g m1 m2 upon d square we put capital F. So new force of gravitation F1 is equal to 4F. It means that the gravitational force increases by 4 times. So the distance is halved by keeping their masses constant, the gravitational force will increase by 4 times. So this is the first numerical. Now we are moving toward the second numerical. In second, let me read the question. The mass of the sun is 2 into 10 to the power 30 kg and mass of the earth is 6 into 10 to the power 24 kg. Here mass of the sun and mass of earth is given. If the distance between their centers is 1.5 into 10 to the power 8 kilometer, find out the gravitational force between them. We are going to find out the gravitational force between the sun and the earth if the distance between their center is 1.5 into 10 to the power 8 kilometer. So solution. Here, first of all, let us write what is given in the question. Here, mass of sun m1 is 2 into 10 to the power 30 kg. It is given in the questions clearly. Likewise, mass of the earth m2 is also given 6 into 10 to the power 24 kg. Like that, distance between them is given as 1.5 into 10 to the power 8 kilometer. Okay, now we have to think a little bit on this point. Here the distance is given in kilometer. Here mass m1 is given in kilogram, it is the SI unit of mass. M2 is also given in kilogram, it is also the SI unit of mass, but the SI unit of distance is meter. But here the distance is given in kilometer. It means that we have to change the kilometer into meter. So we know that 1 kilometer is equal to 1000 meter. So while changing kilometer into meter, we have to multiply it by 1000. So what do you get after multiplying? 1.5 into 10 to the power 11 meter. So we change kilometer into meter by multiplying by 1000. So universal gravitational constant G is not given in the question, but we have to know it. So universal gravitational constant capital G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. This is the value of universal gravitational constant. Now gravitational force between sun and the earth is what? We don't know. We have to find it out. Okay, now we have F equals to G m1 m2 upon d square. This formula we have derived from Newton's universal law of gravitation. We are now familiar about this formula. F is equal to G m1 m2 upon d square. This formula helps to find out the gravitational force between any two bodies. Okay, F is equal to G. The value of G is 6.67 into power minus 11. We have put the value of G, then value of m1, then value of m2, and value of d. Distance is 1.5 into the power 11 whole square. Now we have replaced the values of different symbols in this step. Now we multiply the upper one. If you multiply all this by, you can use your calculator, we can get 8.004 into 10 to the power 44, and if we square the given value, we can get 2.25 into 10 to the power 22. So finally, if we divide this, we can get F equals to 3.56 into 10 to the power 22 Newton. So this is the gravitational force that exists between the sun and the earth. So this is the answer. So today we discussed about force. We read about geocentric theory, heliocentric theory. We have some knowledge about gravitational force. Then we read about Newton's universal law of gravitation. Then we derive F is equal to G m1 m2 upon d square. We talk about universal gravitational constant also, and after that we just finish doing two numericals. So today we are going to end our lesson. I'll try to make the video of remaining topic in coming days. That's all for today. Thank you for watching. Keep learning.